afternoon, guys. So today we will be in this meeting for our problem statement, which is about a patient with right hand injury, and then we want to make a diagnose, and we want to prevent from doing surgical. So I'm Muhammad Abdul as the chairman. So later on, I will pass to our team leader, Shamin, to provide about our data, and then we can conclude something.
Assalamualaikum warahmatullahi wabarakatuh. And my name is Muhammad Shamin Aziz, and I am the team leader for the technical team. So I would like to introduce for my team members. This is Afiq, this is Fakrul, this is Nabhan, this is Samit, Lukman, and Azwan. So today we would like to suggest a few methods for the patient which has right hand injury, and the patient demands for not taking the surgery with, by using non-invasive method. Right? Okay.
Assalamualaikum. My name is Lukman Hakim. So, like the chairman mentioned, the patient, as they described, is a male, and we assume is around 30, and he has a weak to use the muscle. So, it's due to the muscle strain where he overuse his muscle. So, as the team leader said, that he don't want to do the surgery. Maybe just because of his financial problem, or maybe other else. So we decided to use our physiotherapy, which is hand grip. The system that we should use must be performed with low impact because of due to the muscle strain. Grip strength is strongly associated with height, weight, and gender. Therefore, we decided to use the hand grip test, which is dynamometer. From my research, the hand grip strength norms for males, the dominant hand mean is around 48 kg, and the non-dominant hand is around 45 kg. But if for females, the dominant is around 32 kg, and if non-dominant is around 30 kg. So I will let Shamin to explain more about the dynamometer.
Dynamometer methods.
Kau tak bawah sikit, tak nampak macam kau tengok phone tu.
So our team would like to suggest a few methods. First is by using the hand dynamometer itself. Basically, hand dynamometer, there will be two types, which is the analog and the digital. And otherwise, if by using the hand dynamometer we can't get the accurate reading, then we have to refer by using the EMG. So further explanations will be explained by my teammates. So that is our best suggestions for treatment or for the physiotherapy for the patient.
So ni digital kan? Hand dynamometer. Okay, for the digital method, what do I have for you is the hand grip dynamometer. The hand grip dynamometer is used to measure the maximum isometric strength of hand and forearm. So, how to use it is the patient in a standing position, and the elbow is bent 90 degrees to the side of the body, not against the body, to the side at this position, and at a neutral position, and then deep breathe in, breathe out. So as the patient breathes out, he would have to
strain the hand grip dynamometer for 10 to 15 seconds for the reading to be accurate. This must be done for like 5 to 10 times, so to get the average value of the reading. So this would be the digital technique. The analog technique will be explained by my colleague later on.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azwan. As like my teammate said before, now I want to talk about the analog system that we will use. In analog, they have two types of system that we can use to detect the muscle. So firstly, we have spring system where the method is same as Mr. Samir said. We have to stand and then our hand must 90 degree and then we must pull the spring. For this type, it may be not suitable to use because this type is maybe too strong to use because we must see the patient itself because maybe our patient is have some pain in the muscle, so it's okay. Maybe make the patient hard to pull the spring because for the spring we don't know type of the spring. Maybe the spring is the spring is hard or something, and then for the that's all for spring. And then for second type is hydraulic. Okay, for the hydraulic, this system is very difficult to use because the machines that we need to use is so heavy and have a lot of method that must be followed. So I worry that the people that need to manage the system maybe do not have the proper way to use the thing, and we maybe not get a suitable reading for the muscle. And then okay, that's all for the analog system. Right, so after my teammates have been explained about the hand dynamometer, so if the patient didn't get the accurate reading, so what I am suggest is we have to back to the EMG. So by using the EMG, we can detect whether there is a muscle activity in that patient hand. Sorry, it's not.
Control within the spine. Thank you for Tamhan for briefing us about EMG procedure. So I will explain a little bit about precaution before doing the EMG test. So for the first one, before the EMG, the patient must do not take any verification for the first one is when you schedule your EMG, you need to stop taking any prescription or over-the-counter medication. Next, you must take shower bath to make sure your skin and the patient's skin, if have some oil, it can remove easily. So other precaution is the neurosystem specialist conduct the immediate will need to know if you have certain medical condition before the immediate. So that's the basic procedure before the immediate test. That's all.
Right. Right. So after my teammate had explained about the hand dynamometer, if the patient didn't get the accurate reading of the hand dynamometer itself, then we have to use the EMG method. So, which is by the EMG we can detect the muscle activities in the forearm of the patient. Right. So, for the EMG, Nabhan will explain about it.
Assalamualaikum warahmatullahi wabarakatuh. Thanks for our chairman because proposed me to explain more about the analog configurable technologies for EMG signal processing. Okay, first of all, we need to know how the system of the EMG signal acquisition and processing works. Is first of all, the instrumentation amplifier is play the vital role for the system because from the surface electrode for the EMG signal, we can detect the electrical potential from the muscle, and then it passes through the high pass filter, which can detect the small signal, and it has passed. Secondly, it has passed through the low pass filter. And then we can detect the EMG signal through the oscilloscope, and then the RMS to DC converter can give the RMS output, which is the specific signals to detect the bad signals. For the noise, can reduce the noise, and then lastly, we can detect the voltage comparator to produce the output of the signal. So the system, the design of the electrical prosthetic gripper using the EMG and linear motion approach, which can, the advantage of these proposals is it has the low noise in the oscilloscope, so we can detect the clearing of the signal, and we can detect the fluctuations and some of the disease we can detect from the signals, and we can refer to the doctor to diagnose the problems, and we provide the solution. How we can provide the best solution for our EMG.
Right, so after the EMG have been explained by and the preventions explained by Nabhan and Fakun, so if there are any misconduct or the machinist cannot be operated well, then we have to make a PPM, which is planned prevention maintenance. Right, so this method will be further explained by Mr. Taufik, right? So Mr. Taufik will explain about the PPM and the SOPs, right?
Okay, for the extra question, so we have to do the planned preventive maintenance for the machine. For HP, I have the checklist from Ministry of Health Malaysia. So they have they have 8 parts of this checklist. The first thing is on the machine for the qualitative task. Then we need to check the machine. For the example, we need to check chassis, mount, power cord, accessories, and valve. For the preventive maintenance task, we need to clean and check battery, replace battery, and filter. So for the quantitative task, there are nothing to do for the quantity task because we don't need the result from the vibrator. So lastly, after we do the task, we need to do the electrical safety test.
Right, so after Mr. Afiq explained about the PPM and Mr. Fakrul also explained about the preventions of the EMG machine. So this is my recommendations and about my findings and my understandings. So firstly, I would like to suggest by using the EMG machine, so that it can detect the muscle activities, right? So the second method is by using the digital hand dynamometer, right? So hand dynamometer is a simple device which can get the accurate result. And third is by using the analog hand dynamometer. So
I think for the AMG, we need to have a power supply because to make sure this machine work properly, we need to have a suitable power supply for the AMG. So I have come up with my block diagram for the power supply. In my block diagram, it will have first the input of the AC. After that, we have transformer and then rectifier. After rectifier, we will get the output of the DC. So let me explain more about the transformer. For the transformer, the function of this transformer is to step down the high voltage of AC that we get from the input to low voltage of AC. After that, after we get the low voltage of AC, we have the rectifier. So the function of the rectifier is to convert the AC voltage to DC. But for the DC, it will have some varying output, and I think it's suitable for our machine. After that, lastly, we have the output of the DC load line.
But may I interrupt? Yes. Okay. I'm not saying what he said just now was unapplicable. It was wholly true to be denied. But I seriously think that rectifiers are not suitable enough to be connected to devices. I mean, we need something smoothing, like a filter would work for because if you use rectifier straight to the device, then the DC is not smooth, it's unsmooth and very varying for the device. So I suggest we add a filter to ripples, but it's not perfect as well because the ripples will still have voltage falling. But again, we can still add another one, which is voltage regulator. So by adding the filter, we are making ripples, which is more to a straight line than DC's. You know the graph, right, sir? Okay, so the regulator is to wholly eliminate the ripples. So it will be a straight line to the device. It's a very effective way, I would say. So the voltage regulator also works as a cut-off, I would say. The overload protector and also thermal protector to prevent overheating or overloading of current to the devices. So it's a safer and more effective way to execute this power supply system.
Right, Mr. Zamir, thank you for the suggestions and also Mr. Azwan. Right, so back to the analog. So the analog mechanism is have two types: the spring and the hydraulic. So, but I can't make my decision by my own self. I have to further discuss with the Mr. Chairman first, right? Whether how it goes. Right. So after I've discussed with the Mr. Chairman, so Mr. Chairman did agree and stood up with my suggestions. So firstly, we have to use we will use the MG method. Thanks to Mr. Sami and Mr. Hazwan for the explanation. Right. So second is by using digital. Lastly is then we will further use the analog. Right. So I will pass to Mr. Chairman for our conclusion for our meeting and our appointment today. Right. So.
Alright, for now, I agree with the conclusion that the team leader has made. So, thank you for your guys for the idea. Okay, but if there is any changes or there is an improvement that we need, I will make a meeting like this in another time. Alright, okay, that's all for today. Thank you guys. Today we would like to present about our finding for our BDL. So my name is Muhammad Abdul and I'm the chairman. And this is my team leader, Muhammad Jamil. Without any further talk, okay, first our task is basically to find and solve our problem, which is about a patient that want to avoid surgical. So on the first week, when Sir Shah did this task, we already gather our group member, and then we gather our information before we do the ML session. Okay, after this, my group will explain more. So I will pass to Shah President.
Right, thank you, Mr. Hafiz. So I am the team leader and my name is Muhammad Jamil. So I will take about 3 minutes and I will go through about our report. Right? So we can scroll down please. So basically what are we doing is about the hand grip, right? And mainly we are conducting and experimenting, gathered some information about the hand and monitor itself, right? So the patient also have each requirements or the requirements for us to not to have the surgery, and it is male and it is 30 years old. So scroll down. This is the hand grip and scroll down. Scroll. Wait. Alright. So basically, my team member will explain furthermore about the digital hand dynamometer. Right. Next. This is the hand dynamometer. Scroll down. So, alright, and this is the analog. We have the two types of the hand dynamometer. Next. Scroll down. Right. Okay, good. And right. Scroll down. More. Right. And next is the power supply. Block diagram also my team members will also explain about it. Right. So I will end my presentation. So the next I will pass it to. So I will pass it to Mr. Lukman for the next explanation.
Assalamualaikum. My name is Lukman Hakim, and I'm going to brief about the medical instrumentation system for the treatment with block diagram and possible circuit diagram. This is why we mention the patient description, because this is the problem based learning. So we assume that the patient, if a patient says a patient, so we assume the patient because it's easier for us to understand the requirement for the hand grip dynamometer. First of all, before we brief about the dynamometer, you guys need to understand the hand grip strength first. Because the hand grip strength testing result can vary with different protocols that are used. It's important to have established testing protocols to ensure accuracy and easily to duplicate results. For example, the hand grip dynamometer that we will brief after this, handles should immediately be adjusted to fit the patient hands, or if that's not possible, the handle should be set at the same setting for everyone. When testing the handle, setting should be used even if the strength of the right or left hands vary. Also, it's important to perform multiple tests in order to get the maximum score. When testing the hand grip strength, it's mostly three types of things, which is the gender, male or female, the dominant and non-dominant hands, and the ages. This is the hand grip norms, hand grip strength norms. That's why we assume that he is male and males and at the age of 30, because we want to know the strength, average strength for male and also female, dominant hand and their non-dominant hand. Okay, for the hand grip also can be used in rehabilitation. For example, we can use big grip hand exerciser. It's easier to use tools for patients in the big grip hand exerciser, which can be used to facilitate hand flexion and improve grip strength. With a simple design, the grip exercises are simple to use and are available in 4 different resistance levels to accommodate patients for varying strength level and can be upgraded as grip strength improves. Other than that, Kendo ergonomic hand grip. Most of you guys and ladies know what is this, because most of the, as you know, the one that you always grip, and that's the level and kg. This is the name of the device. Another okay. The use is also as same as the upward. They have the 5 different version, color code according to strength level. This ergonomic hand grip is an excellent choice to start beginners or patient new to hand rehabilitation after an injury. It can be used to level to improve their strength, and better for athletes to looking improve grip strength to enhance their athletic performance. Whether assessing grip strength as part of hand injury evaluation or assessing overall health, hand grip dynamometer are important tools to use to complete a full evaluation to track patient progress with the right hand dynamometer. Practitioner can get a full picture of a patient's strength, deficits, and create a successful treatment plan. Okay, then I will pass to Shamin again to explain more about the dynamometer.
Right, so after, thank you Mr. Luman, sorry. So the first thing is not to have the surgery, right? So we have brainstormed and we have come up with some few options, right, for the hand grip. The firstly is the digital hand dynamometer, and secondly is the analog hand dynamometer itself, right? Right. So this is about the digital hand dynamometer. So this part will be further explained by Mr. Samit. Right. Thank you.
Right. Assalamualaikum. Hi everyone. And right. First up, we're going to start with digital hand dynamometer. Honestly, it's a very easy to operate device, nothing much complicated. It's very easy, isn't it? Let's start again. The digital hand dynamometer is engineered as a professional training device for hand grip strength. It's suitable for any doctor's office, physical therapy clinic, engineering lab, or even gym. Adjustable central knob allows the device to be adjusted for different hand sizes and preferences. So it doesn't matter if the hand is big as Shamon's or small as mine. Okay, 19 definable uses with options for gender and age installed, along with the ability to save and recall test results for each user. Means that you can compare the results, even save for further use. So that's it. Each test run is rated weak, normal, or strong based on the filter, which is age and gender data entered for each user. Easy switch from LBS to kg at any time, including for last recorded data. Means that if you recorded the data with pounds with LBS and later you want to review it back with kgs, you can just with one click. It's a very easy device. So moving on to features and details. The first is accuracy. Equipped with high precision string. High precision string gauge sensor. The hand dynamometer gives you accurate momentary digital reading of gripping power. Measuring capacity is 198 lbs or 90 kgs with the division of 0.2 lbs or 0.1 kg per second. It is also user friendly, as I mentioned earlier, because you just have to squeeze the hand dynamometer with maximum isometric effort for at least 5 seconds. After testing, the LCD will automatically display the maximum grip value and grip value status bar showing the status of weak, normal, or strong according to age and gender preset for each test. Means the patient would just have to stand and hold the meter 90 degrees elbow and just squeeze the hand dynamometer for at least 5 seconds. Ta-da! The result will be showing on the LCD. So, okay, easy to diagnose or easy to read. Large LCD screen shows all measurements clearly on the same screen. Displayed measurement include user code, age, gender, grip value in pound or kg, and grip status. Engineered for home, sport, and clinical use with 2 times AAA batteries included and 5 years warranty included. So it's for everyone usage. I mean, like anyone can be using this, not just doctors. So it's a very precise and easy to use, which is very suitable. Alright, that's all for the digital hand dynamometer. Next up is analog hand dynamometer, which will be explained by Ed as well.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azwan. Now I will explain more about analog hand dynamometer. Okay, first I will explain about the procedure, how to use the analog hand dynamometer. Because analog hand dynamometer, we have 2 types of manometer, that is spring and hydraulic. Okay, first I will explain about the procedure on how to use the firstly, as you can see, the subject holds the dynamometer in the hand. It doesn't matter on right or left. And after that, the arm must at the right angle and the elbow by the side of the body. The handle of the dynamometer is just ikut baik. After that, ada tes. Okay, after that, the handle should rest on the middle of the 4 fingers. You can see it on the picture. So we use the
our fingers to put on the handle. After that, when the patient is ready, after that he or she must squeeze the diameter with maximum asymptotic effort. Okay, and then it must maintain about 5 seconds. After that, it shows the reading of the scale. So we gonna see first types of handlemeter, that is spring hand grade handlemeter. Okay, as you see in pictures, this type is called as medley handlemeters, as I searched from the Google. Okay, this type have a different design from hydraulic and pneumatic handlemeters. It makes use of velvet spring. Basically, it's used spring to show the reading. After that, okay, the next type is hydraulic hand grade handlemeter. As before, the type is using the spring, but this type is using hydraulic. So hydraulic handlemeters are convenient for taking quick and accurate readings of grade strength compared to the digital hand handlemeters. So this type is more faster than, as mentioned as I made before, digital handlemeter. But for this hydraulic handlemeters, it have some heavy weight for the patient to lift. So maybe some older patient or patient that have something wrong in their hand hard to carry this thing. So maybe this type not convenient to the patient that have that problem. Okay, after that, another handlemeter are very less expensive, and the digital one will run on battery. Okay, so this one is battery. So we have no problems about batteries. Okay, so that's all for me about the analog handlemeter.
Right, thank you, Mr. Azwan. So next we will explain about the power supply diagram. So I would like Mr. Azwan.
Please, Miss. Okay. In this I will talking about
Right, sorry. Right, so after we had about the explanation by Mr. Azwan and Mr. Hamid about the digital and analog handlemeter. So this is about the EMG, the another option for diagnosing the patient's hand. So I would like to invite Mr. Azwan. Yes, Mr. Azwan to explain about it.
Okay, for the machine that we're using for the patient, we must have a power supply to operate the machine. So this is our block diagram for the machine. So in our block diagram we have transformer, rectifier, filter, regulator, and after that we have load. So we'll more explain about the transformer. Okay, about the transformer and okay, as you can see from the diagram, firstly we have the transformer. Right? For the transformer, the function of the transformer is the main thing is to step down high AC voltage to low AC voltage for the suitable usage of the machine. So as you can see, that's the function of the transformer, that is
for the step down. So it is not suitable for alternate circuit as the AC unless we include a rectifier and sporting resistor rectifier convert AC output to DC output. So after we have the transformer, we go to the rectifier. For the rectifier, it will convert the AC input to the DC, but DC output is still varied. So the varied DC output is suitable for lamp heaters and extended motor, but maybe it's not suitable for our machine. Maybe we have some problem. So after that, we will use filter to smoothing the output waveform. So now I will pass to Samir to explain more about the steps.
Okay, after adding the filter, the smooth DC output still has small ripples. It is suitable for most electronic circuits. The filter smooth the DC varying greatly to small ripples. Just now you saw the varying DC was very varying, so the filter smooths it. But we still need a regulator, which would help a lot more to produce a fixed voltage and a straight load. Here, this is the regulator aided. The regulated DC output is very smooth with no ripples at all. It is suitable for all electronic circuits. The regulator eliminates ripples by adding DC output to a fixed voltage. It also helps to cut off, heat cut off, and it prevents from overheating the regulator. So straight to look. So that's all for the power supply. What's good? So I'll pass it back to Mr.
Thank you, Mr. Samir. Right, so next up is the third point. Is it about the data acquisition, the DAC. So I would like to invite Mr. Namhan for his further explanations.
Yes, first of all, I will discuss as fast as possible for the data acquisition program. So the first one, we start from the instrumentation amplifier, and then we go firstly through the high pass filter, low pass filter, RMS to DC converter, and voltage converter, and lastly we go to the switch on and control. So we take the image MG signal from the low pass filter. Next, and then as you can see, it's a little bit complex, so we simplify the findings. So actually the MG signal is within a range from microvolt to a low millivolt, 0 to 6 millivolt peak to peak, or 0 to 1.5 millivolt RMS. So basically the MG signal range from 0 to 500 Hertz range, frequency domains. So next. Okay, so the amplification and filtering circuitry, we use the preamplifier to have a high common mode rejection ratio, CMRR, and then a high input impedance, short distance to the signal source, and strong direct current, DC signal. Okay, next. Next. So this is a high pass filter. This is the diagram, a schematic of the circuit called the silently high pass active filter with a corner frequency of 20 Hz and roll-off rate of negative 12 decibels. So as you can see, this is the schematic diagram. This is the amplifier used. Okay. Then next. Okay. Then figure 4 show that the schematic of the fourth order. This is the second order and this is the fourth order serenity and serenity high pass active filter with corners frequency of 20 Hz also. On the serenity low pass active 2, 4 and second order, and we use 709 Hz. Next. Okay, this is the diagram of the graph of the amplitude response versus frequency. So we can see the line A is the amplitude of the second order low pass filter. This is the line A. See, line A. This is the low pass filter, line A. Line B, low pass filter also, and the line C. This is line C. The application of the fourth order low pass filter. So all of this we use the low pass filter. And then next. Okay. We use the surface electromyography, which is the electrode that allows to acquire information about muscle activity for non-invasive method, because it have some stimulation for the electrode, but it's not major disease. So we use the double differential or double differential technology for the 3-line electrode potential for the accurate and more precise measurement. Next. Okay, this is the implementation of the proposed electrode circuit. This is the circuit. Next. Okay. This is the ideal double differential amplifier. BD. This is the double differential amplifier. Next. Okay, AMG measurement. Next. Okay, we can see the measurement of the AMG signal from the muscle activity, the electromyography. So this is the shape of the signal. Let's see. Next. Okay. This is the forearm flexion. This is the this is your forearm. Okay. This is the signal. The sample of the signal for forearm flexion. This. Okay. Final. Okay. Based on our study, so the final. We use the AMD amplification filtering circuit consists of 3 amplifiers, second order high pass filter, second order low pass filter, and inverting amplifier, and second order low pass filter. For we collecting the data from the journals, from ball squeezing like this, okay, and forearm flexion like this. So it's the same method used for the amplifier, because we detect the muscle activity. Then, this is the sample of diagram. Okay, this is the ball squeezing and this is the forearm squeezing. You can see the difference, right? The difference again. This is higher than the ball squeezing. Okay, this is the difference between needle electrode and surface electrode. So the needle electrode is invasive, the surface electrode is non-invasive, and the needle electrode in contact with single muscle fibers, and surface electrode pick up many overlapping spikes. So that's my part. Okay, I'll proceed to the fellow friends. Next.
Okay, sudah boleh sebut from Datuk and Dr. So we continue for the presentation for his strength system. So basically, in every medical device or other equipment, we need to have it its calibration system. So for hand grip, this hand grip calibration, we need to make sure this the result we obtain or we measure that it has accurate value. So first, this procedure for calibrate for hand grip system. So basically, this just procedure for hand grip calibration. So we need some load to measure the result for each calibrate procedure. So basically, the dynamometer should be equal within 2 and 3 for the average of 3 calibration target. So we for our calibration, we must make sure the deviation for each sample not more than 3%. So after the device calibration have been checked, you may be able to make accurate adjustment on the curve. Otherwise, it may be necessary to send the dynamometer to manufacturer for repair calibration. Sometimes hand dynamometer ni moment. So sometimes this equipment we cannot calibration itself. That's why we need to send to manufacturer for calibration process. So I think we continue for.
Assalamualaikum. My name is Muhammad Aiman bin Muhammad Yazid. So system fault condition. So in which the suggested system fail to supply sufficient power source to the system in order to operate and function properly. So, what are the cause of the fault in power system? Okay, under normal operating condition, power system equipment or lines carry normal voltage and current, which is result in safer operation of the system. But when the fault occurs, it causes excessively high current to flow, which cause the damage to equipment and device. This fault so we need a rechargeable battery to prevent the device from a power failure when we run the machine. So we don't want to have a power failure lah. Next. Okay. For backup, we need a backup battery with high capacity. So the operation of the device will keep longer and still go on. So next for the extra progression, actually we need to do the electrical safety test to the machine equipment. Okay.
Okay, and we have to do the PPM. You know what is the PPM? Okay. PPM is planned preventive maintenance. So we need to maintain the equipment for about 6 months or 1 year per machine per device. So this is the task that technician need to do. First, okay. This is this is example of PPM checklist. First time? Very excited. Thank you. So they have 7 parts that technician need to do. First is part 1. So part 1 is asset detail. So technician must do the detail, then test the apparatus of EST, DST, no EST. At the back, okay, okay, okay. Steady. Okay, next. For the next part is qualitative task. Qualitative task is like basic checking for the equipment. You understand? At the back? Okay. The next part is preventive maintenance. So the technician must clean the equipment, clean the lead electrode, battery checking, filter checking. So for the next step, the technician need to do the quantity task, but for this machine, it is not applicable for the quantitative task. Okay. Lastly is electrical safety test. So if the electrical safety test is failed, the machine is, need to be repaired and suggested not to be used. So anyone want to see this checklist? Oh no, it's okay. Okay, that's all for me.
So we have come to the end, and this is our conclusion. So previously, after what we have done the BBL, so what we have done now, and firstly we are suggesting we have 3 options to use for the patient, which is the ear, right hand injury, right? So there are 3 options. First is the EMG test, and secondly is the digital hand anemometer, and thirdly is the analog hand anemometer. So in order, the firstly we will use is the EMG test because it is much safer, and we also can acquire the signals, the muscle activity cells, the muscle activities, right? If the reading or the result is not obtained accurately, then we will use the digital hand anemometer. Because why? the digital anemometer is very easy to use, of course, first of all, and secondly is we'll get the accurate data, and it is much more safer and much more easier. And because of the thanks to the strain gauge sensor, it will require the high precise and high accuracy data. And if we did not get the accuracy data for 5 or 6 repetitions, and we have to back to the analog. But the analog is very hard to get the accurate data because the gauge is moving like rapidly. So someone need to observe the needle of the gauge. So that's our suggestions, and agreed by Mr. Chairman sir. Right. So anything to that? Right. There's a promise. Open for any question. Q&A questions. Q&A sessions.
Suggested we explain in what condition.
So, in what condition?
The device that you need to apply is that.
We do the electrical safety test when we do the PPM. So before, after we do the 7 tasks here, then we do the electrical safety test to make sure the equipment is ready to use and no current leakage from the equipment device. Oh, very. Understand?
Next question. Okay, sorry. For my opinion, from our experience, the EST is a part of PPM procedure. So, EST not to detect some form of faulty condition, but if others medical or any medical equipment we test with EST, the result we fail or we fail or pass. So if the equipment result appear fail, though that machine need to be repaired.
Are you clear?
Crystal clear, right? Next, please.
Okay, my name is Katarina and I'm from Okay, my question, I have 2 questions. Okay, first, for Roman 4, external features including automation control or feedback system. What is the meaning of automation control? And another question is, you suggested that there are 2 types of analog hand grip system, right? And from both of them, which one is better to use for the patient and why? Okay, thank you.
You can distribute the questions. I'll answer second one. Right, so I will answer the second question. Right. So between analog and digital, right? So both have.
For analog, there are 2 types.
2 types, alright. Analog, which we have the hydraulic and the string. Right. So for spring, both has pros and cons. Spring, it is not suitable to use for the person like 35 or 40s because spring maybe like if sometimes some of the spring anemometers the spring are too stiff, so you might not able for the patient, because patient have the energy, right? So for the patient to get the result. But so about the hydraulic, I think the way around. Yes. Right one? Spring is easier because spring is much easier and it's very soft to handle, to grip, but then to grip. That's why the spring we can get the reading by hundreds of thousands of patients just like that, because it's not too harmful for the patients. So we'll say that spring or
What age of the patient? What age?
huh?
What age for the patient? For victim? Spring is this, right?
What
At what age? Suitable.
around 20 to 30s.
I believe hydraulic is for patients that have strength.
Yes,
Spring
so
for the
spring is more suitable for the elders, because I think hydraulic has a heavy weight of has to grip and to, because the procedure as mentioned before, we need to there's a degrees and we have like this and then we need to grip the spring. So for the hydraulic it's more heavy than the spring. So we suggest spring for the others. For the others. For the others. For the others. You clear?
So for external feature, grid system for automation control lah. So basically for my research in the latest grid system for the net is DSD+1C. This hand dynamometer, it can it has itself automation control to make sure the result correct or not. Basically, this is the best handrometer based on our research, because not just can basically use the manual calibration, but you can use the data acquisition using the manual, using the system there. Using the AP system NDA 100C general purpose resistor amplifier. This for this type hand dynamometer automation controller. So basically this example of the dynamometer, I have so many dynamometer type. So for me this is the best equipment for hand dynamometer, because it not just can has manual procedure control, but it can use data acquisition system. So
Does it have feedback?
yeah, basically same like we use for that view system, but so it has it set software and it has the after we do the data acquisition, same as the data sheet. So if not, we must need to send to the magnification. Basically.
Now, based on your explanation just now, it looks like it has self-calibration. Is it related to self-calibration? Based on your explanation, it has its own self-calibration.
Yeah.
Any other question?
My name is Nadia and I'm from Rosie. This is just a simple question. I want to know what is the full name of AMG and what it
Masa movement contraction kasut ni
So, anything else?
All right, thank you very much. Give the last
Dia pakai tu pandai. Betul kan? Betul tak? Betul. Kita lihat ke? Betul kau masuk lah. Boleh cakap lah. Boleh suggestion. Nak betul masuk? Masuk. Mesti cakap.